Assignment 2, Part 2. In this video, we're going to solve inequalities, which we've already done, but we're going to look at a couple or a few special cases. So the old scenario was when you had something like this: 2x is less than 2. You divide by 2, and you get x is less than 1. Okay. Now, we've been solving more complicated equations than this, but that's the general idea. The next piece is if we get something like this. Let's say we have 2x plus 4 is less than 2x plus 10. Okay. Now notice we have 2x's on both sides. If we subtract 2x, they cancel out on both sides, and we're left with 4 is less than 10. So the question is this true? Is this a true statement? Is 4 less than 10? Yes, it is. So that tells us the answer to this is all reals, which will be a clickable option in ALEKS, or all real solutions. We'll look at it the next page. All right, in scenario 3 that we're going to look at is, let's say you have 2x plus 1. Let's go with greater than 2x plus 5. So once again, I made this a very simple equation. If you subtract 2x from both sides, they cancel in both spots. You're left with 1 is greater than 5. Is this true? That's what you're always asking yourself. Is this a true statement? Okay, is this true? Is 1 greater than 5? Is 1 bigger? No. So therefore, there is no solution. So we're looking at these few scenarios. Obviously, the equations are a little more complicated than this, but once you get down to the end, you either get an answer, you get all reals, or no solution. So let's take a look at an ALEKS question or two. Okay, here's a question from ALEKS. See, you have the option no solution, all real numbers, or you get an answer. Okay, I'm going to solve this. If you want to pause the video, go ahead. I'm going to continue on. I'm going to distribute the 3. So I get 15x. 3 times 5x is 15x. 3 times 6 is 18. Is greater than or equal to 15x plus 18. Okay, there's a bar there. We know that means greater than or equal to. So if we subtract the 15x, which you don't have to show the workout, I'm just doing it for notes. Some of you probably can just see this. You get 18 is greater than or equal to 18. Okay, is 18 greater than or equal to 18? Is this a true statement? Yes. So this one would be your all reals, because this is a true statement. Okay. So that was question. That was A. B. So if you want to pause it and try it, and then either look at the result or watch the rest of the video or rest of the segment, go ahead. Distribute the 5. 30 minus 5v, I distributed, plus 5v is less than 28. So minus 5v plus 5v are on the same side. We combine like terms and they cancel. So there's nothing there. Is 30 less than 28? Is 30 less than 28? No. So the answer is no solution. Here are 2 more examples. If you want to try them, pause it. If you got this and just want to move on, just fast forward the video, move on to what you need. Okay, I'm going to run through this quick. So distribute 35v plus 5 times 6 is 30 is less than 35v plus 28. So we know those cancel. I'm just shortcutting now. Is 30 less than 28? Is 30 less than 28? No. So this is a no solution. And last problem, distribute the minus 5. Distribute the 5 over here. Combine like terms. Negative 5x plus 15 is greater than or equal to 15 minus 5x. Some of you might be able to see if these are exactly the same, so it's all reals. But let's say you add the 5x to both sides. They cancel. Is 15 greater than or equal to 15? This only works because you have the bar here. And yes, that's true, so it's all reals. And of course, I didn't pick anywhere you get an answer. You could solve this out and actually get an answer in this section. Okay, I'm going to drop back and give you a couple of notes, but we're combining two topics into one because they want us to graph our solutions and then write them using interval notation. So we just combine these two topics together. Okay, so let's say you get x is greater than 5. Okay, so we're going to look at graphing the solution and interval notation. To be honest with you, when we get to like pre-calculus, calculus, interval notation is really the one we use. We don't really graph things, but we use interval notation in calculus all the time. Okay, so x is greater than 5. So they give you a number line in ALEKS. I'm just going to write out a couple of numbers. I like drawing it above because it's easier in ALEKS. I think you put it on the number line. So x is greater than 5. So there's no bar here. So what we use is an open circle. So that's a key. No bar means open circle, and it goes to the right. Okay. So no bar underneath tells us open circle. In interval notation, we don't want to include 5. So we write 5 with a parenthesis to infinity because it goes on forever, and infinities always get a parenthesis because it's not a finite number. You can't count to infinity. It goes on forever. So infinities always get a parenthesis. Let's go with x is greater than or equal to 5. Now for this one, the only difference is we're going to use a solid dot, a filled in dot, because of the bar. So the bar gives us a filled in dot. And for interval notation, because it's filled in because of the bar, we use a bracket. So I say bar bracket, kind of bar bracket. So 5 comma infinity. With an infinity always gets a parenthesis. So if it's not included, parenthesis, open circle. If it's included, is the bar closed bracket. Okay, that's a filled in circle. Let's go with a couple more. Let's go with x is less than 1. So x is less than 1. We're just going to go the other way now. So open circle, going to the left. So this would be, you always start interval notation, you always go smaller to bigger. So this goes forever down to negative infinity. So we're going to go negative infinity, comma 1. There's no bar. It's an open circle, so we use a parenthesis. The parenthesis kind of reminds me of like an open circle. Like if you put two parentheses together, it kind of makes a circle. I know it's kind of a different way of looking at it, but it just works in my brain. X is less than or equal to 1. Okay, same. Like I said, they give you the number line. So closed circle, filled in, going left. So this one would be negative infinity to 1 with a bracket. And another one we will see is if we have -2 is less than x, which is less than or equal to 4. One, two, three, 4. So there's our 4. Okay. They'll give you a number line. So -2 doesn't have a bar. So when it's written with less thans, so -2 is less than x. So I look at that as x is greater than -2. This will always be, as long as there's lesses here, and that's how they typically write it, this will be the smaller number. So -2 gets an open circle because there's no bar, and 4 gets a closed circle. And this is saying the x is between -2 and 4, so we just connect the line. And that's our solution. And the way we write this in interval notation, we would go -2 with a parenthesis, 4 with a bracket. So those are most of the scenarios, at least the different pieces we need right now. You just have to understand the bar, no bar, bar. So no bar right there, bar. Open, close, parenthesis, bracket. Remember, infinities always get a parenthesis. Always parenthesis, always parenthesis. Here, bar, closed, bracket. Here, open, open, parenthesis, closed, closed, bracket. Or bar, sorry, closed circle, filled in circle, bracket. All right. All right, so we're going to graph. One more piece we need. Okay, one more piece that we're going to need is, actually, you know, all right, so we're going to stop this video here so it doesn't get too long, and then I will continue this in the next video.